Good day to Dr. Afik and Dr. Jafaria. The topic that our group will present on is regarding arsenic contamination due to volcanic eruption in southern Kyushu Island, Japan. Our group consists of 4 members: Bryan, Cheong Yi, and me, Li Qing.
As an introduction, on April 19, 2018, Mountain Iwo, one of the Kirishima volcanoes in the southern part of Japan, erupted for the first time in 250 years. This has caused flow of mud and acidic water into the nearby Naga River, poisoning water with arsenic at a high quantity that exceeded the environmental standard 10 grams per liter. Consequently, public health is severely threatened by arsenic contaminated water used for drinking, food preparation, and also crop irrigation. Samples and chemical potentially found in this volcanic eruption is volcanic ash, which is composed of finely particles of fragmented volcanic rocks. This can be bring by the wind to a wide area around the volcanoes, and also gases such as carbon dioxide, sulfur dioxide, and also hydrogen sulfide, lava, and also volatile elements such as arsenic, lead, mercury, and cadmium. And these elements can have some detrimental effects and consequence on human health and also environment. And in this presentation, we will discuss about the sample preparations and also the analytical methods to determine the arsenic concentration.
In the analysis of arsenic concentration in the river, sediment sample and water sample can be collected. Sediment sample can be collected is because arsenic can be released in the form of arsenic oxide or sulfide as solid form from the ash of a volcanic eruption, so it was deposited at the riverbank. Due to the water-soluble properties of arsenic, it could also be found in the water sample as arsenic 3+ or arsenic 5+. Sample preparation is important because it will help in obtaining a clean sample containing the target analyte before subjecting it into the analytical instrument. A clean analyte can lower the limit of detection, increase sensitivity, and further produce a more reliable result. For the sediment sample, it should be sampling using the dredges stored in polypropylene plastic bag and freeze to avoid decomposition by bacteria. The sample preparation for sediment sample can be divided into 2 parts, which are physical preparation and chemical preparation. A series of physical preparation can be applied for sediment sample. First, it can be dried at around 100 degrees Celsius to remove the water molecule and volatile organic impurities. This drying step also transforms the semi-solid sediment sample into solid form, which is more easy to handle and homogenize. Next, the sample can be sieved to get rid of large solid impurities such as rocks, and the grinding step can further homogenize the sample and increase the extraction efficiency. Next, cone and quartering method can be applied to obtain representative sample replicates. There are 2 types of chemical preparation method that could be applied for sediment sample. The first one is acid digestion. Acid digestion will dissolve the matrix and transform the analyte into a form suitable for analysis. The 2 types of digestion available are open digestion or closed microwave digestion. However, microwave digestion is always preferred when budget allows because it has a higher efficiency and easy to be automated. The acid used in the digestion is concentrated nitric acid. The acid digestion is done by adding the acid into the sample, heat at open flame or microwave to enhance the dissolution of the sample. The next chemical preparation method that could be applied is etching. The purpose of etching is to remove the organic compound in the sample and leaving the inorganic compound behind. The first type of etching is dry etching. It could be done by heat the sample in the furnace at 450 degrees Celsius to 550 degrees Celsius by adding magnesium nitrate as etching aid. The next etching type is wet etching. Wet etching is done by adding the acid into the sample and heat the sample at the open flame. Besides, sulfated etching is another etching type that could be applied. It is done by adding the concentrated sulfuric acid into the sample and heat until the white film stop evolve. It is noted that acid digestion is a more preferred chemical preparation method than etching because it dissolves the matrix effectively and increases the extraction efficiency, while the etching is focused more on remove the volatile organic compound from the sample.
For water sample, the sampling can be done by using sample tip or camera bottle. The camera bottle sampler consists of stopper on each end that can be held open when sampler is lowered down by a line to a desired depth. This stopper can then be triggered to close when a metal cylinder called messenger is dropped down. In terms of storage and preservation of water sample, it can be done with proper storage in polyethylene bottle and preserved by freezing to prevent decomposition by bacteria. Moreover, addition of ascorbic acid and hydrochloric acid can be a preservative of arsenic 3 and arsenic 5 ions. After sampling, we need to convert the sample to a suitable form for analysis. Thus, in terms of physical sample preparation, filtration can be utilized to eliminate any solid impurities. Besides, the chemical preparation of water sample with inorganic arsenic analyte can be done by solid phase extraction (SPE). By undergoing SPE, the sample can be purified and concentrated since only desired compound with specific chemical properties will be retained on the solvent while others will be eliminated. The types of SPE columns suitable for analysis of arsenic are strongly anion exchange, strongly cation exchange, weakly anion exchange, and weakly cation exchange. Overall, water sample is more preferred than sediment sample in analyzing the concentration of arsenic sample in the river. This is because water sample enable direct analysis of arsenic concentration without excess preparation that would increase the possibility of loss of analyte. Sediment sample, on the other hand, is originally in semi-solid form, which is hard to handle and homogenize. Besides, a lot of physical preparation is needed to obtain a clearer sample for sediment sample, which is labor, cost, and time-consuming.
So in this part of the presentation, I'll explain more on the sample analytical methods that we use to analyze the arsenic content in the water sample. So first we have inductive coupled plasma mass emission spectrometry, or for short, ICP-MS, which is actually not covered in our syllabus. But in this slide, it shows the schematic diagram of ICP-MS, as well as highlighted some important parameters in this analysis, which is the isotope of interest, which is arsenic 75, as well as the dwell time for the MS, which is 200 milliseconds, which indicates that the analysis time is rather short. Now for the next sample analytical method, we use anion exchange chromatography, or ion exchange chromatography for anion, AEC. So as you can see on the screen, there's also a schematic diagram of how AEC works. So the basic principle is it uses an anion exchanger to extract the positively charged ions. In this case, it is arsenic, which has a +3 or +5 positive charge. So some of the important parameters include the column temperature, which is 30 degrees Celsius at room temperature, gradient elution mode, and 400 microliter per minute flow rate for the mobile phase. And the injection volume only requires 100 microliter, which is a small volume and is actually safer to use. Now moving on to the third analytical method, which is a commonly used method as well, which is high performance liquid chromatography, HPLC. On the slide, there's also another schematic diagram to show the whole process of how HPLC takes place. So HPLC basically is based on the concept of elution and retention time of the analyte of interest, in this case arsenic. So here are some of the parameters that are important and should be highlighted. Is a column temperature at RT, room temperature as well. The flow rate is a gradient elution from 0.6 to 1.5 milliliters per minute, and a quantitative loop of 20 microliter. So overall, the overall analysis time will be approximately 12 to 15 minutes for all the sample and analyte to elute out of the column. So in the three previous slides, we have mentioned about the different analytical methods that could be used to analyze the sample, water sample, for arsenic content.
So in this slide, I'm going to focus more on the comparison between all three different analytical methods and to decide which one is the most suitable for analyzing arsenic in water. So in ICP-MS, we have the advantages where it's multi-element, can account for many different elements. It has a large analytical range as well as a low detection limit, and the sample preparation is very simple. But however, for the disadvantages, the laboratory setup cost is quite high, and the high purity gases such as argon gas is needed, and it also requires a high level of staff expertise. Moving on to AEC, it has a high yield, high selectivity, and the use of buffers are non-denaturing, meaning that the analyte or sample will not be affected by the use of buffers. However, the sample must be loaded at a low ionic strength so as to not interfere with the anion exchanger. And the changes in pH can greatly alter the binding profile of the resin. So, as shown in our report, we also mentioned that there's a change in pH when we use AEC to consider for different conditions. And also the particle size, such as larger size of ions, can greatly influence the resolution of the spectrum. And third of all, HPLC. It has a high speed, efficiency, and accuracy, and also is cost saving for the reusable column. However, for the equipment, it is quite pricey, quite expensive, and it is also more complex as it could have multiple settings, such as the gradient illusion or isocratic illusion, and it can also have different composition of mobile and stationary phase. Overall, as the standard method used in our journal article or in the journal article that we have studied, ICP-MS is the more preferred method and is actually more commonly used as the standard method.
In conclusion, analytical methods such as ICP-MS, AEC, and also HPLC are employed to measure the arsenic concentration in the collected samples, allowing for an assessment of the extent of contamination of the aquatic ecosystem, human health, and also the surrounding environment. Differentiating between various arsenic species such as inorganic arsenic, organic arsenic, and also arsenic bound to particular method can provide insights into their potential toxicity and also environmental behavior. Analyzing the speciation and fractionation of arsenic helps in understanding its mobility, potential for leaking and or remobilization, and its long-term fate in the affected river system. Thank you.